Hello everyone and welcome back to the third episode of the Rust book series, and today we are going to learn about variables, data types, functions, comment, control flow, while loops, loop, for loop, etc, etc, etc. So let's start. So the first thing we need to learn is keyword. So what is a keyword? Keyword are just some special name that are reserved to the programming language itself. Let's say you can't name a variable let interface is equal to something. It is a reserved word. You need to use it in that way that it is defined in the Rust programming language. Let's say you can't use fn in place of variable name, you can't use let in place of a variable name. These are the things that hold a meaningful space in the Rust programming language. So currently we are in a project that is called Rust Common Concepts, and let's say if I want to create a variable, let's say let is equal to 5. See, I'm not able to create a variable that is named let because it is a keyword itself. Const, because const itself a keyword. Let's say I want to create a variable name that is fn. Look, I cannot create a variable name that is fn because fn is a keyword itself. So in this way, the keywords are reserved in the programming language itself. Now we come to the variable part, and take it as an example. You have a fruit box and you can store multiple type of fruits inside that. You can store apple, you can store banana, you can store mango, and you can also store collection of fruits like you can store mango and papaya at the same time. It depends on you. The box is called variable in Rust, and there are two scenarios. The scenario one, you just put the mango in the box and you lock the box, you don't have a key. And in the second scenario, you have a key. So when you have a key, you can basically take out the mango, you can put more mangoes and do alteration with the amount that is inside the box. But when you don't have the key, you can't do anything what's inside the box. You can't put out the mangoes like without the key, obviously. So when you don't have the key, that is immutable by default, that cannot be changed. So in Rust, when we declare a variable, let's say I have created a variable x and have stored 5, and I want to change that variable. I want to assign let x is equal to x plus 1. See, here it is giving me a error, a compilation error. Why? Because it is saying cannot assign twice to a immutable variable. Immutable is a box without key. If I want to change the value of x, I need the key, and the key is mute. Let's say I have got a box with the key, and with mute key I have unlocked that box and take out the mango or assign more mangoes or just do any calculation with that. So the key is the mute, and by default variables in Rust are immutable. You cannot change any variable until unless you have marked it mute. And also let's understand one more example. Let's say this is x is equal to 5 and we want to print x. We want to print x here, and let's say let's run this function cargo run. As we can see, it is 5 here. Let's reassign x is equal to 6. X is equal to 6. Look here, like we cannot mutate immutable variable because this variable is immutable by default and we cannot change the value of x. It is a different case if we write let x is equal to 6 again. That is a different scenario. We will learn about this later. But here we cannot change the original x. If we write let x is equal to 6, we are basically creating a new variable that is called x and that stores 6. So that is a whole different scenario. But right now we are assigning x is equal to 6. That is not possible because this is immutable. If we put the key, this become mutable, and we can print again the value of x. And see what happens. As you can see, x is equal to 5 and then x is equal to 6. So this is how mutability works in Rust. Next, as I told, I explained this is like the error number, and it won't compile because we cannot mutate a variable without marking it mute. Next, we will be moving forward with term constant. So we have learned about variables, and now we will learn about constant. So constant word in Rust is used to store a data that will be constant throughout the program, that will be constant throughout your code base. Let's just take example of speed of light. Does speed of light ever change? No, it won't. So it is a constant for whole program. Let's say you have a physics constant, or you have a chemistry constant, or if you have any constant that is there, you can put that value. Let's say you have a constant interest, we are calculating principal interest, so simple interest, I'm sorry. So the interest rate is constant for you, so you can use a term constant for that variable. Const x is equal to 100. And look here, I was able to create a variable, let's say let x y is equal to 32, without even type annotating, without even telling the type of that variable, of that data. But if we are creating constant, we need to explicitly tell about the type of the data that we are storing inside a constant. Rust is a statically typed language. That means that the type of all the data types are need to know before the compilation. So if we are denoting anything with constant, we need to tell what type of data we are going to store inside constant. And for annotating the type, we do, after the variable name, after the name, we do x colon, let's say i32. We will learn about this later. What is i32, what is u32, what is f64, f32, etc, etc, etc. So this is constant. So constant are always immutable and always typed. That means we must tell the compiler what type of data it's gonna store beforehand, before it is compiling, before the runtime, right? So three things we need to keep in mind here. No mute is allowed. Constant are always constant, the name itself. We can't change the data inside the constant. Type must be annotated for constant, and we can write something, let's say, just for example, it is this, and we can also write const 3, let's say, is equal to u32 is equal to some data. What will be the value? Let's say value is 1 2 3 4 5. So we can also write this data, but we can also break it into some simpler form. Let's say multiplication of 16 to 16 to 60 must be something, 60 multiplied by 60 multiplied by 3, it is 10,800. So we can write 10,800, but it is also convenient to see the value 16 to 16 to 60. So constant can perform some mathematical expression at compile time. We can either denote as 10,800, or we can either denote it as a form of expression itself. And at last, naming convention of the const variable are, we should always use capital letters with underscore between the words if there are multiple words. Now we will move to a shadowing. Understand shadowing in this way: we need to create a variable that is of same name and we want to store some value inside that. Let's see the code. Here inside the function main we have created a variable that is called x, and the value is stored, that is a number, and it is 5. Now we want to create a new variable that is called x only, and we want to store some value inside it. So we do this by creating a new variable using let keyword. Here do you see that, like, let x is equal to x plus 1. Here we are not doing x is equal to x plus 1, we are explicitly using the keyword let. If we do x is equal to x plus 1, we gonna change the value of x, the upper x, the original x. But here we are creating a new variable and shadowing that older x, like just shadowing that value inside a new variable that is called x. When you see the stack, you will see x and the new x that will be storing the old x plus 1. So that means we shadowed the old x. The old x is still there, it haven't gone anywhere. Now let's understand this in a better way. This is a big room, an outer room, and there is just one small room inside that big room, and that one small room is a scope that is started by a curly braces and ended by a curly braces. And inside that we have created another variable that is called x, and we are storing the value of x multiplied by 2 there. Let's understand this in a proper way. Look, outer value of x that is marked white is 5. This is the new x that we have created. Let's name it let. This is the new x that we have created, and it stores the old x plus 5. And inside that we have used a new keyword that is called x, and stored the old x, like this x, because we have shadowed the old x with the orange x, and this is the orange x that will leave all the function, like, because we have shadowed the white x and we got a new orange x that will be a single source of truth for whole function. So if we go inside this, if we go inside another room, we only know the orange x, okay, and we are creating a new variable that is called x and multiplying x multiplied by 2. So for this inner room, the outer pink x is the single source of truth. So this is how it works. Let's understand this in the code. This is the value x we have created, x is equal to 5. Now if we run this program, as you can see, at line 3 we have written println. It is just like console.log in JavaScript print and Python. So x is equal to 5, and this line we are ensuring that x is equal to 5 via println. Now we are creating a new variable that is called x and storing the original older x plus 1 inside that value. Take it this way. We are creating a new variable that is called x, and this variable is whole different from old x. Just take it as a different x, different version of x. It is not the old x, right? So x is equal to x plus 1. Let's also add println here. As you can see, the value of x is not changed because this is the x that will reap throughout the function. This is the new x for that function. And when we go inside a room, the room knows that the original x, there is a variable that is called x and it has value 6, and inside that we are creating a new variable that will store the original x multiplied by 2, right? So we are creating a new variable that is called x. Let's take it in a way x3, and we are storing this pink into 2, so it will now store 12. As you can see, this x now prints 12 because this x multiplied by 2 is the new x, right? And as the scope ends, the value of x is dropped again. So this x will live inside this scope, and this x will live inside this scope. As you can see, this is the scope for outer x, and this is the scope for the inner x. Every variable lives inside a scope. So for this x, this is the scope, and for this x, this is the scope, as you can see, right? For this x, this is the scope. So this is the work of scoping in Rust. You can confirm this via the println statements. And finally, as the scope has ended, the original x whose scope was this, its scope will end here. So before that, if we write println, it is actually 6, this one, right? Now we will understand the difference between shadowing and mute more. So in shadowing, we create a new variable, but in mute, we mutate, we change the value of that original variable. Let's understand by an example. Let's say here there is an variable named space, and here it is of type string, and later we want to create a new variable that is named space only, but we want to store the length of that space inside that variable. So we apply a method on the variable space and convert that into a number. Here, like, you can see one thing, the type is also changed when we create a new variable. So we are creating just new variable and storing something into it. So it doesn't matter you are storing any type. But in mute, you can't actually change the type. Let mute x is equal to 5, or let's take this example only. Look, here we are not using the let keyword again. We are creating a new variable that is called spaces, and it is of string type. Don't get confused with &str, we will do it later. And we are mutating that space. We are not using the let keyword, we are mutating the space keyword only, and we are converting space dot into space dot length. And look here, it is not compilable. It is saying that expected string but found usize. It is expecting a string. When we mutate a variable and we add something, we will add in that time. The type should be reserved, but here we are changing the type, and that is not possible in mute. We have to reserve the variable's data type, as I have said here. And if we want to change, we can use the let keyword via shadowing. Let's come to the type annotation. As I told, Rust is a statically typed language. That means we must know the type, the Rust compiler must know the type of that variable before compiling. It is not like JavaScript. JavaScript, you don't annotate anything. You just write let x is equal to something and let x is equal to string variable, anything. But in Rust, you also need to tell the compiler that this is of type number, this is of type like boolean, this is of type character, and everything. And that helps in long term. You don't get any panic, or you don't get any errors in runtime. So how do we tell Rust that this is of type anything like int or uint, anything? So for that, we do let x, and after writing colon, we define the type. Let's say it is of integer, and it is of signed integer of type 32. Type 32 means it can store 32 bytes, 32 bits, I'm sorry. And let's say 6. In the same way, if you want to declare char, let's see, char is equal to something like this. Okay, so we must annotate the type in Rust, and this is type annotation, and every value has a type in Rust. You can't just write let x is equal to something. You have to provide the type of that variable in Rust. Next, we will learn what are that types, what are the multiple types that are used in Rust. And there are many types. One type is scalar type, another type is vector type. Understand type in a way. Let's again take the example of the fruits. We have mango, papaya, banana. There are different types of fruits. So think different type as fruits. As the same way we have length for distance, we have, this is just a unit, okay, just a measuring unit or just a different thing. So let's understand the primitives of Rust. Let's understand what are these types. So first we are going to discuss the scalar types. Scalar type is of single type. Let's say you just have mango, you just have tomato, you just have potato, something like this. And here comes the first, integer. Integer is just a number component but without fractional component. Let's say it's just number 1 2 3 4, anything -1 -2 0, but it doesn't have a fraction like 1.0. It is not there, but 1 is there, so integer counts up to this. We will learn about i8, u32, usize. These are just a thing. Let's say I. What is I? I is of integer type, signed integer, and u32 is, u stands for unsigned integer. And what is the difference between signed and unsigned integer? Let's say you are writing a number that is 24. When you write 24, you don't explicitly write positive there, you write just 24, so you don't need to sign it, and it is a positive number. So remember it in a way. When we don't sign, it is an unsigned integer, and basically it is only positive number. And when we do unsigned integer, we only take positive number. At the same time, when we do signed integer, it can have sign, so it can have negative sign, it can be neutral, and it can be positive itself. So for I, it is signed integer, it can have negative, positive, and 0 value. For unsigned, it is 0 to positive anyway. Usize is just a maximum amount of that size can be, like we will learn about usize later. Take usize in a way that it is a maximum amount of space that is allocated by that thread or that stack, anything. Floating point number. Floating point number is a number with decimal. F32, F64. If you have learned binary number, you must have known that numbers are stored in binary form. So I8, there is 8-bit boxes. F32 is F32-bit boxes. There are 32 bits in which the number will be represented. At F64, 64 bits. U32, 32 bits as well. Boolean, true and false. We already know what is Boolean. Character is a single character in Rust, like A, B, C, D, anything, but it should be single. So that is a single character. So let's come to the integer type. As I told, there are two types of integer, signed and unsigned. And by default, when we assign anything, it is a 32. Let's say if here I write let x is equal to 5, and as you can see, by default it annotated it as i32. So by default, the Rust compiler, if you don't annotate, the Rust compiler or Rust analyzer will annotate or assume it as i32, so that we don't make any mistakes. This bits matter when we want to store our required, like if you want to store number between 1 to 255 only, so why would we store it in 32-bit? We will store it in 8-bit. That saves the memory of the CPU. Okay, so let's say, and yeah, what is from what range to what range? As I told, U8 stores number of, U8 represent 8-bit boxes. So how much number you can accommodate in 8-bit boxes? it is 0 to 255. Ultimately, when you convert 255, it will be accommodated in 8-bit boxes. You must have learned how to convert a number, decimal number, into binary number. And in the same way, signed integer will contain 255 numbers, but from negative to positive range. So it is from minus 128 to 127 that counts total of 255 numbers. And if you are not sure what size you want to use, you either use i32, that is by default given by the Rust compiler. Next, it is just a representation of how we store number. Let's say decimal, we can write it like this. Hexadecimal, you must have already seen in blockchain or in Web3 space, your account address or your public key. It starts with 0x something, so it is a hexadecimal number. Octal, it starts with 0O, and binary, you all know in computer language everything is converted into binary, so it starts with 0B. And if you want to represent a byte, this is annotated like this. And yeah, underscore represent the separator, like this is equal to this. Now we will understand about integer overflow. So let's say you have a number that is 10 and you have stored it inside a U8, that is 8-bit, and it can store only from 0 to 255, and you multiply that number with, let's say, 10 into 100. Okay, so both number are U8, but when you multiply them, they are not gonna be accommodated inside a U8 integer. If you create a new variable that is sum, let's say you created let x is equal to 10, and you annotate it by U8, and again let y is equal to 100. Okay, so both variable are good here and both are U8, but let's say when we want sum U8 only, and x multiplied by y, and if we want to print this value, let's see what happens. So you can see it is giving me an error that attempt to compute 10, that is U8, and 100, that is U8, and which would overflow. That means it is not it won't be able to accommodate inside 8-bit memory. If you convert 1000 to binary, what will be the number? Let's say 1000 to binary, so it is this. And as you can see, it is 1 2 3 4 5 6 7 8 9 10, but it only stored 1 2 3 4 5 6 up to 8-bit only, so it is called overflow. The number exceeds beyond its size. For that reason, we have two options in Rust, one that is in debug mode and one that is in release mode. We just saw the debug mode. Our program panicked. As you can see, it couldn't compile, it panicked. In release mode, what happens? It automatically performs a wrap. So now what is wrap mode? What happens is, let's say you have a number U8 and you can store only 0 to 255 number, and let's say your x is 255 and you have added 1 to it, so it can't store 256. So what will it do? It will round up to the next least value. So U8 can stand 0 to 255. After 255, it will again start from 0. It is like that. So 257, it will start from 0, then 1. 258, 2. It's like that only. For handling overflow, we have various methods provided by Rust. The first one is wrapping. So what does wrapping add do? Let's see. Let's say let x u8 is equal to 255 and let y is equal to x dot wrapped add 1, right? Let's see what happens in println. When we do cargo run, as you can see, it is 255. It should be 256, but as it is U8, it cannot accommodate 256 in it because there are only 8 box. Let me show you 256 in binary U8. Just 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, there are 9 boxes, and if we write 255 in binary 1, 2, 3, 4, 5, 6, 7, 8. So this is the maximum number that can get accommodated by a U8 number. So it wrapped to a next number, that is the least number of that field. U8 least number is 0. So it get converted into that. Same happens for multiply, division, addition, etc. What does checked do? So it checks if the number can be accommodated inside that value or not. If it is not, it will give you none. Let's say wrapping add checked add. And if we do cargo run, okay, as you can see, it give me none because it knows that it cannot accommodate the value 256 inside a U8 data type. Let's say if it is 251, and when we compile and run the program, it will give us 252 because it will give some and none are type. In Rust, when Rust doesn't have a null type, you can't really write there isn't any value. You have either some or either none. That prevents from panicking in Rust. So either there will be a value or either there will be a none. There will be a value that is none value. So checked add give us some 255 or it will give us none, that it will tell yeah this is the value or it will tell no it can't be added. In the same way, overflowing, it will give us a overflowed value plus boolean that yeah it is overflowed or not. Let's say we write overflow 255, and if we true, it works like the same as before. It works like same as before. Let's say this how the wrapping works, and after that it will give yeah it overflowed. In the same way, saturating, it clamps to the minimum and maximum of that type. Let's say if we add clamping means like it is reserved at. As you can see, x plus 1 it can't happen, so it clamped to the maximum of that value in U8. So 256 will be converted into 255 only, that is maximum of U8. Next we will learn about floating number. So floating number, it is same like integer only, just we will have a decimal of numbers after decimal places. F64, F32, it is basically number of bits here. Default is F64 because it provides us a more precision while performing any numeric operation. You can perform any operations that you perform in any language, like you can add, you can subtract, you can multiply, you can divide, you can truncate, and you can always get the reminder on all of these things. These are some basic information, and these are some basic operation. You can perform it in Rust Playground or in your local. Boolean type. Boolean type, as always, it is just true and false. Either there will be a condition, it will be used inside if statement and basically control flow statement in future. It just says true and false. It has just two value and it is stored in 1 byte. 1 byte is 8-bit, like it's just like AU8. Now character, basically A, B, C, any emoji or anything, and it suppose many character. It can support any, like as you can see here, it is a different type of character. It is normal character, it is an emoji. So many things are counted inside a character, and you can see here a 0 with space. A space also is counted inside a character. We have learned about scalar type. Now we will learn about compound types. Basically, scalar type, as I told, it is a single kind of fruit, but in compound type you have a basket of fruits. You will have banana and apple together, you can have banana, papaya and mango together, and this type of fruit baskets are called compound types. So what is a tuple? It is just a grouped value of various types. Let's say you want to store a number, a character and many things inside one variable. You can store it via tuple. You can have multiple types. Just think of it like you can have multiple fruits. And array, at the same time, you will have same fruits, a basket of same fruits. You can have basket of only single type, that is called mango. You can have only papaya, you can only have grapes and many things. So you can have a single type in array, but you can have multiple type in tuple, right? So let's deep dive in tuple type. So first we will understand how to declare tuple. As you can see, we can declare a tuple like this. This is type annotation, as I told, and here we are annotating different types of different value inside the tuple. As I told that we can store multiple type of fruits inside a tuple. So we must also specify that this is mango, this is papaya and this is grapes, and we annotate via colon. So there is not a single entity here, so we enclose them inside a parenthesis, and this way we create a tuple. You can see I32 is of 500, like I32 500 is of I32, 6.4 is F64, 1 is U8. In the same way, after we created tuple, we can destructure them. What is meaning of destructure? Let's say the box has many fruits, but you don't know the type of fruit, and you name them yourself, like you give a nickname to in every element inside that. You give nickname to every fruit inside that box. You do this by typing this. You say let x, y and z is equal to tup. Here it means x is named, 500 is stored inside x, 6.4 is stored inside y, and 1 is stored inside z. Let's say there is 3 type of fruits, so you just name apple, mango, papaya, and that will direct it to the first, second and third element as you have written in destructuring pattern. Now if you want to print, as I told, like let's write this here. And if you want to print, you will get the value of y 6.4. Y is written in second place, and you can get this value because it is also in second place. And imagine this is basically second place, but in tuple the number starts from 0. So this is 0th place, first place, then second place. Okay. Later on, if you want to access, let's say you have a tuple and you want to access an individual value, or you want to access some value inside it. Let's say you want to access the second element, but in tuple it is not second, the number start from 0. In array number start from 0. So 0 1, you want to access the first element. Print ln first element in tup is, let's say, x dot 1. Not x dot 1, it is tup dot 1, my bad. If you cargo run, you can see the first element, not first, it is second element, but number start from 0. So second 0, then 1 1 is the second element. So it is 6.4 here, and we can access via y because y is placed in second position while destructuring. So we can get y value 6.4. At the same time, we can access the second element via this. If you want to access the, basically it was not first element, the number itself confused me, it is second element, and this is first element, and you can access the first element via top.0, and as you can see, the number 500 got printed here. And there is also a type that is called unit type, that it doesn't have anything, it is just unit type. If the tuple doesn't have anything, it will be a unit type. We will learn about this later, we will get more exposure to this. You can say just it's an empty return type. If we are not returning anything in the function, we just write unit. Now the array type. Array type is collection of something of same type, right? Either you collect same fruit, either you collect apple, either you collect pineapple, either you collect anything. Okay, so it is of same type and it is of fixed size. And one more thing, array is stored in stack, it is not stored in heap. So when will you create array? You will create array. When will you create array? You will create array when you know that I will need data of this particular fixed size. I will know, let's say you are using, let's here example, you are using it for all the name of months. So you know there are only 12 months. So you create an array that is of fixed size and that will store only type string and it will be name. So how do we create array? Either we create like this, the entities will be enclosed via square bracket, and it will be like this. Look here, this is 1 2 3 4 5, it is only of number. January, February, March, it will only of type string. If you want to create the same number of multiple times, let's say you want to create 5, if you want to create 5 times, you can just write let x is equal to this, and it will create 5 threes for you, right? This is basically type annotation. If you want let x is equal to, if you want to say let x or let numbers i32 5, you can do this. It is just saying there is an array number and it will have 5 elements that will be of type i32. Okay, so here it is written about vector. Vector we will learn later. Vector can grow in size, so they are stored in heap. Now how to access array? Basically you can access array just like tuple. You can just do it via you want to access some data. Let's say let array 1 is equal to 1 2 3 4 5, and you want to access any element. So println array1 dot 0, and if you want to access the second element, it will be, as you can see, this first and second element are 1 and 2. Now in Rust, there are only 5 numbers, and you accidentally access the 6th number. What will Rust do? Rust will panic because we are accessing the number that is not present in the array, that is not present in the memory. In C, it will basically print you something. It will show you the data that is present in that memory address, and that was basically a bug in C. Anyone can access that data, anyone can manipulate that data, but in Rust it checks it is of length 5, and it checks if the length exceeds from the length. If the index number exceeds the length of the array, it will panic and the Rust won't compile. So it is a good point in Rust. Basically, you get a bug-free code. Now we already have met main function. So it is a starting point. We write functions starting with fn keyword, and function is something that will store our logic. We don't have to write redundant code. Let's say you want to add two variable x plus y, and you always write x plus y, x plus y. Let's say there is a function where you write x and y, and it will add it for you. So you write a logic inside a function. You don't always write multiple things. Let's say you have a physics equation, you have an algorithm, and you're writing whole logic. You are writing whole logic for sorting. You are writing whole logic for calculating palindrome. Now you just have written that logic inside a function, and you can reuse that inside main function. You don't have to write everything. You just have to write the function call. So that is a use of function. Now how to create function? We create function via fn keyword. Then we name a function. If there are two words, we will separate them via underscore. After that, we will write parenthesis. Inside the parenthesis, there can be something like that will be inputted inside the logic. Like if we are creating speed is equal to distance upon time, and there is a function that calculates the speed. So what we need? Distance and time. So we will put distance and time inside this thing. We will learn about this later. So we write function in this way: fn, the name of the function. Then this declares that it is a function, and we can write parameters inside this. And this is the body of the function where we write the logic of the function. How we call that function? We just write the name of the function, and we write parenthesis after that, and we call that function. Now let me tell about parameters, and basically sometimes it is called arguments. What is parameter? As you can see in the code, this is main function, and we are calling another function, and we are calling another function that is called print labeled measurement. What does another function do? Another function print the value of x. Now where this x came from? There it is a temporary variable, you can say. Whatever we pass in this, it is printed here. Like this value will live inside this function. At the same time, this is a function, this is value, and this is a label. So whatever we will put inside this, while calling the function, it will be printed here. So these are just temporary value that we put while defining a function, so that we can use it later. and we must always annotate the type. As I told, Rust is a statically typed language, so another function, if we don't annotate it, we won't know what will be the outcome. Let's say here, if we don't annotate i32 and we are performing something, let's say here it is string and we are performing addition, so addition in string doesn't make sense, right? So we will always annotate the type. A temporary variable, every variable has a value and has a type. So every variable, it is a temporary variable, you can say it will have a type, and in the same way it will have a type. You can write it in the command, you can write it in your local to understand how it works. If we write, you can write single parameter with this, and if you want to have multiple parameter, we will use comma to separate them. Technically, basically, as written here also, these are called parameters, and when we put real number, they call it arguments. It doesn't matter, you just have to call the number. Now, statement versus expressions. Just take it in this way. Statement is something that you are talking to someone and just you are letting them know something, and expression is you are asking something from someone, you are always getting an answer. So statement is something that you are telling, and expression is something that you are getting in response after you ask something. Let's say we declared a variable that is y is equal to 6, and we are just telling the compiler that this is y is equal to 6, this is a variable and stores a value 6. And in the same way, we do expression. Let's say we do 5 plus 6. We ask someone 5 plus 6 and they reply us with answer 11. So that is an expression. In Rust, it is used. So in Rust, there are multiple ways of representing what expression is and what statement is, and most probably, and the most basic way is to use semicolon and the curly braces. Anything we write inside a curly braces become an expression if we don't use semicolon. So let's understand via this example. Right, let's run cargo run. As you can see, let's first understand this. Here, if we write anything, if we write semicolon, it becomes an statement. Basically, we are just telling the compiler that this is 5, and we need to write let x is equal to 5 to tell that it is an expression. But if we don't write a semicolon, we are just telling that this is 5, and whenever I call this function, you need to give me 5. One thing I forgot to explain you is a return type. A function can give you answer, a function cannot give you answer, a function can do anything for you. If you write a function to calculate sum, so if you tell someone to calculate x plus 1, and if you tell someone to calculate 4 plus 5, what will it give you? He will give you an answer in response. So the function will also give, like we ask 5, and it will give an answer in response, and that will be of some type. It can give answer in number, it can give answer in string, and various anything. So here function 5 will give us a number in the answer, and what will it give? It will give 5 because we are returning 5 here. In the same way, this function, what does it do? It will take a variable that is x and it will return a number. What will it return? It will return a number. How will it return? X plus 1. X plus 1 will be a number. And in the same way, if we write semicolon here, it won't return anything. It will write expected i32, but it return a unit. As I told before, if anything doesn't return anything, it will return a unit type. So let's say if this function doesn't return anything, then this will be a valid function because it doesn't return anything. But if we want to return it something, we first have to write return type, then after we should make it an expression rather than a statement. So how to make it as expression? We eliminate the semicolon here. So in this way the Rust tells that this will evaluate to an answer, and as we call, let x is equal to 5. So now how we call a function? We use parentheses. What will 5 give? 5 will give me 5, the value 5 here. So it is basically let x is equal to 5. Then we will print value of x, and that is printed 5 here. Also, yeah, now we have come to the a little end, and we will know what are comments. So basically we are a developer, and if a developer want to work with this code base, how will it understand? And if we want to explain some functions, if we want to explain what this function does, what this function does, what this function does, we annotate them. We just write comment for that, like this is plus one function, it adds a value, or something like this. Anything, you just write English inside the comment if you want to tell anything about in code base. So single line comment, multiple line comment we can do in this way. Now we will learn about if expression. So if you want to execute anything with a condition, if you want to execute a piece of code, if you want to return some value based on a condition, you write it with if statement or if expression. You use if there. The idea is simple. You just have to write if, and after that there should be a condition. Just say you question someone, and you should get answer in either yes or either no. Let's say you ask, are there mangoes more than 10? So they will answer yes or no. You should not ask them how many mangoes are there. They will answer 10. So they are not giving you a boolean value, they are giving you an integer. But you should answer question in such a way that you will get a value in either true or either false. That is called condition. So the idea is simple. We write if, and then we write a condition here. Is number greater than 5 or not? We will get answer in yes or no. We won't be getting answer in any other form. We won't be getting answer in boolean. We won't be getting answer in any integer or anything else. We will getting answer in only boolean form. So is number is greater than 5 or number is less than 5? We will get yes or no. And inside that, if this condition is true, this code will execute. Here we have written println. So whatever you write inside this will execute, and if this condition is false, this will execute. So let's test this. Let's say if let the number be 3, right? And if the number is less than 5, then we will see condition was true, and if the number was greater than 5, we will see the condition was false. So we will do cargo run, and as you can see, we got printed condition was true because this number was less than 5. So the condition is true, and we got in this way. And if we haven't written this else, and let's say it was this condition, what would have been printed? See, nothing got printed, because if we don't write else, the compiler will skip the else part. It won't even execute. It won't execute anything. So as you can see, if we write else part, then only we will get the false conditions value what we want to do in false condition. But if we don't write anything inside, if we don't write else, we won't be getting any value, or no, none of the code will be executed. Then uh, let's say there are two conditions for us, like if this is this, or if this can be this. Let's say here, let number is equal to 6. If number is divisible by 4, then print number is divisible by 4. So if the number is divisible by 4, here it means number divided by 4, its remainder. So if this remainder is equal to 0, that means it's divisible by 4. So the condition will be true and the number will be printed. But we also want to add one more condition. So for that we use else if. There is one more condition that can be true too. So if the number is also divisible by 3, so we will write, we should not say also, we should say if. So if the number is divisible by 3, will print this thing. Or if the number is divisible by 2, we will print this. Or if none of above 3 happens, we will put this statement and this block will be executed. Let's say it in the code. So right now the number is 6. So 6 is not divisible, equally divisible by 4. It is divisible by 3, it is divisible by 2. So what are the condition we are gonna see? It is divisible by 3, so the code got executed, and it didn't reach the lower value, it got executed by here only, right? So one condition will be executed, and if we comment this out, let's say if we remove this else if, you will see this condition is executed. So the condition that is in upper in value, that will be executed if it's true, and below that it won't be executed. And if we remove this too, the number is not divisible by 4, 3 or 2, because this condition is false and this condition is true now. And if we delete this too, we will get nothing because this condition is not true. Now we can also use if in one more statement. Let's say we want to store largest of two numbers. So let's say there is number 1, and let's name it x, and let y is equal to 7. So we want to store the largest number. So this was all about this chapter, and I will create a different video on loops, specifically on loops. Then we will do some practice questions too. Next we will learn about ownership, and mutability. We already learned about mutability, but we will learn about ownership in next videos. And try doing this questions, and do try wrestlings too. It is a good practice platform, or you can say practice exercise. And we will also do DSA and wrestlings later in the series. Till then, keep hustling. Bye bye.